I'm going to start with the fourth problem, the fifth part of exercise 8.4. As you can see, the problem is this one is simple. 1 plus secant of a divided by sec of a is equal to sine square a by 1 minus cos a. So we have to prove LHS is equal to RHS. So let me begin with LHS. So if I begin, this is sec, and right hand side there are only sine and cos terms, and here we want to write in terms of sine and cos. So there is no sine term here, so I can write secant in terms of cos. So simplifying LHS, secant of a is 1 by cos a, 1 by cos a. So which is equivalent to, now if I take LCM, cos a by cos a plus 1 divided by cos a. This is a numerator. So it is useful to put the bracket, divided by 1 by cos a. So now you can see that again in terms of fraction, I can write like this. If it is a by b divided by c by d, where a, b, c, d is equivalent to a by b into d by c. So this result, this is a, always if there are so many divisions we have to use this result. So this is equivalent to, I'll write the numerator cos a plus 1 divided by cos of a into cos a by 1. So we will reverse the denominator. So cos a cancel. So this will be 1 plus cos a. So now we know that there is this is the expression is in terms of only cos. So we have to simplify. We will try to simplify the RHS now, because we have simplified the LHS. So we have to bring RHS in terms of only cos. So I can write using the identity, sine square theta, sine square a plus cos square a is equal to 1. I can write sine square a is equal to 1 minus cos square a. So if I write like this, and again this one, next I will write like this. First I will write like this. So sine square a is equal to 1 minus cos square a by 1 minus cos a. Still you might ask, what is the use of writing this? Now if you remember this algebraic identity, a square minus b square is equal to a plus b into a minus of b. So this identity is pretty much relevant, and always it is useful to make a result of this. So if I use this, here a is 1 and b is cos a. So I can write this as 1 plus cos a into 1 minus cos a by 1 minus cos a. So now 1 minus cos a and 1 minus cos a will get cancelled. So RHS is equal to 1 plus cos a, which is equal to LHS. So hence proof. So sometimes one side simplification may not be sufficient. So depending on the question, you have to maybe solve both sides to get the result. And this is one of the example. Although this is very simpler, We'll continue with the next question. The fifth problem. Cos A minus sin A plus 1 divided by cos A plus sin A minus 1 minus 1 is equal to cosec A plus cot A. So also in the question it is given that we have to use the identity using identity 1 plus cot square A is equal to cosecant square A identity. So now, so one thing you can notice that here there is no cot or cosec term. So we want in terms of cot. So first I want to bring this LHS, consider LHS. LHS, I want to bring this in terms of cot. So cot is nothing but I can write cot of A is equal to 1 sorry, cos of A by sin of A. And similarly cosecant A is nothing but 1 by sine. So in this way, now we know that both the denominators, now look carefully here, both the denominators are sine. So I can try to divide the numerator and the denominator by using sine. So what will happen? So by dividing the numerator and denominator, I mean that each term in the numerator and denominator will be divided by sine A. So I am considering only LHS. So if I divide each term, cos A by sin A minus sin A by sin A plus 1 by sin A by cos A by sin A plus sin A by sin A minus 1 by sin A. Now what you can observe is that because now it doesn't matter if I divide by a same number, a same expression in the numerator and denominator, because sin A is a common, and if we don't want sin A, then we can cancel it out. So expression doesn't change, the overall expression remains the same. So if I divide, now what will happen? Cos A by sin A is nothing but cot A. I can write this cot A minus, let me write in minus 1 plus 1 by sin A is cosecant of A by, again denominator is cot A plus 1 minus cosecant of A. Now this we have brought in terms of cot and cosec. So I want to, now what to do next? Now just look the numerator carefully here. Now I am using a different thing. Just look at the numerator and there is a 1 here. So if I use this identity, then 1 is equivalent to cosecant square A minus cot square A. So now I am using this identity. I will write like this, cot of A minus 1. Instead of 1, I am writing cosecant square A minus cot square A plus cosecant of A. Now look this carefully. Let the numerator be like this. Let the numerator be. I am not touching the numerator and denominator currently, so let it be like this. So denominator will be same throughout. So 1 minus cosecant of a. So now if I try to open the bracket, and what will happen? Cot a plus cot square a plus cosecant of a minus cosec square. So this should be cosecant of a. No? This is cosecant of a minus cosec square a. So now what I can do is, I can take cot a common. Now instead of this, 1 minute. Now if you try here, what will happen? If I take cot a common, there will be no use. Again, you'll get like, let me try and show you. You might think that we have to take cot a common. So 1 plus cot a. I'm just writing like this because this is unnecessary step. We got to just show you 1 minus cosec a. So is there any use of writing like this? Definitely not. So this is not required. So we have to find some other way uh, to simplify the numerator. This is a numerator. So how we can simplify? Just try to look anything you can find. So now I can, if you look carefully here, I can rewrite this expression as I can rewrite, instead of writing in this way, this is not the way. So what I will do is, this cosecant square a minus cot square a, you know that it is in the form of a square minus b square. So now if I write in that form, let me do a thing. I will take these two terms together, that is cot a plus cosecant of a, and minus sign will be outside, cosecant of a minus cot a into cosecant of a plus cot a. So now if you look carefully, I am just clearing this out because this is not necessary. I just want to show that where the people commit mistakes. You have to think 2 steps ahead while solving the problem, that you get with the practice. So now if I try, now you can very clearly see that this expression, wait, I will use a different thing maybe. This expression and this expression are both the same. So isn't it something which you didn't expect? Definitely you'd have not expected that if you use a simple identity. Again, this is a very simple identity. A square minus b square is equal to a plus b into a minus b. So how it is used? Using this simple identity, this problem now looks much simpler. So now I can, similarly I can take this minus sign inside now. Okay, 1 minute, I will go step by step. I will just continue like this. So this step, if I take this whole expression common, cot A plus cosecant of A, then this will be 1. Here 1 minus of cosec of A minus cot A. Now, if you look the denominator carefully, and now again in the next step what I am going to do is I am going to expand. I am going to expand this in a minus sign. So my term will be cot of A plus cosecant of A into 1 plus 1 minus cosecant of A. I let it be write like this: 1 plus cot A it should be 1 plus minus into minus 1 into minus cot A is plus cot A. So now I can write like this: plus cot A, then minus into cosecant of A is minus cosec of A. So as you can very clearly observe that this is nothing but this is a denominator itself. If I try to rearrange this denominator a little bit, this 1, if I bring this side, 1 plus cot is also having a plus sign and cosec is also having a negative sign. So these both expressions are same. I can cancel them. So the remaining is cot A plus cosecant of A. So which is equivalent to RHS again. So this, you can see this problem was slightly trickier compared to other problems, because there was a chance that you might have got lost here somewhere in between, just as I have shown if you have done something very stupid. So now this step which I am telling, this step, first important step is this one. You have to think and use 1 in the denominator, no need to use it. Similarly in the numerator, again the next step of using the identity. These two steps are very important. So these two steps in the problem are defining, and you have to try to understand the way to solve different types of questions, because trigonometry, it depends on the type of the question, the way you have to solve it. So thank you. I will continue other problems in the next video.